Good morning. So, in this class, we will discuss the consequence of Euler's formula. Okay, and based on Euler's formula, we'll solve some problems, especially problems on planar graph. Okay, uh, so I think you know what is Euler's theorem. So, cardinality of V minus cardinality of E plus cardinality of F equal to 2. That is N minus E plus F equal to what? 2. So, in short, I will write, okay, N minus E plus F equal to 2. So, this is Euler formula. So, N minus E, okay, I will take this is N, this is I will take E, this is F equal to 2. Okay. So the next concept is the degree of the face. Degree of the face. The number of edges incident with a face F is defined as degree of face F. So in counting the degree of face, a cut edge is counted twice. Thus, each edge of a plane graph G contributes each edge of I'll tell you line by line. The number of edges incident with a face F is defined as the degree of F. Okay. So here, what is the degree of F1? Degree of F1 means the number of edges incident with this F1 is what? 3. Okay, number of similar degree of F2 is what? 1, 2, 3, 4, 5. I think I'll start from here. 1, 2, 3, 4, 5, 6, and then 7, 8, 9. So degree of F2 is what? 9. And then degree of F4. Okay, so F4 is nothing but the exterior face. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, F4 is 8. But here in F3, this is a cut edge. So cut edge means, okay, what do you mean by cut edge? Okay. So actually, this is this edge is called a cut edge because if I remove this edge, the graph is what disconnected. So so cut edge is a edge. Okay, if you remove that edge, the graph is what disconnected. So those edges are cut edges. So if I remove this edge, okay, if I remove this edge, the graph is what? Okay, if I remove this edge, so this vertex is disconnected from this portion. Okay, that's why uh, if I remove the edges, the vertex remains same. Okay, the vertex is not affected. So, okay, so maybe you will get a I'll put a diagram. Maybe that part. Suppose you have I think this is the graph like this. Okay, if I remove this edge, so the resulting graph is uh, that's all. Okay, vertex. So this vertex is uh, disconnected from the remaining part of the graph. So that's why they are telling it's a cut edge. So in counting the degree of phase, a cut edge is counted twice. So that's why for F3 the degree of F3 is what? 1, 2, 3, 4, and then it should count this is twice. So 4 plus 2 6. Okay, and then thus each edge each edge of a plane graph or planar graph G contributes 2 to the sum of the degree of the faces. Okay, for example, if I take this edge, okay, this edge contributes 1 degree to f1. Similarly, this edge contributes to one edge to what? 1 degree. Okay. So this edge contributes 1 degree to f1. Similarly, this edge contributes to 1 degree to what? f2. So that is the telling. Thus each edge of a plane graph G contributes 2 to the sum of the degree of the faces. Okay. It follows that if script f denotes the set of faces of a plane graph, then sum of the degree of the faces is equal to twice the number of edges. So the degree of f denotes the degree of the face f. So actually, the beginning of graph theory, we proved some of the degrees of the vertices. Okay, some of the degrees of the vertices we proved it is what twice the number of edges. So this is a new result. Okay, now in planar graph, sum of the degrees of the faces is equal to uh, 2 times the number m of g means 2 times number of edges. Sometimes they will use m, sometimes they will use 2e. Okay. Next, next result. If G is a simple planar graph with at least 3 vertices, then E of G or M of G you can use for edges. So the number of edges is less than or equal to 3 into number of vertices in G minus 6. Okay, it is a simple planar. If it is a planar graph, then this inequality is satisfied. Okay. So G is a connected plane graph. As G is simple, okay, simple. It has no loop and no parallel edges. So boundary of each face contains at least 3 edges. Okay. So boundary means we need okay in the previous diagram also we saw that. Yeah. So each boundary. Okay, here for the boundary we need what? We need minimum 3 faces. Minimum I'm telling. Okay, minimum 3 faces. So, so the boundary of each face contains at least 3 edges. So we have here they are writing summation over I and the number of edges on the boundary of face F1. Fi. This is not F1. Maybe I'll take a snapshot and then I'll explain this portion. Okay. So what they mean? Okay, here. So number of uh, edges edges of face F1 plus number of edges of the face F2 plus number of edges of the face F3 plus dot 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 dot. Okay, so maybe the last one is number of edges. Okay, maybe it is I'll take fk. Okay, totally k faces. Okay, so f1 to fk. So I'm just calculating number of faces in each number of edges. Uh, I'm counting the number of edges of the each face. Okay, so this sum should be greater than or equal to okay this sum. Okay, so total this sum. Okay, greater than or equal to. But we know that each face what I told in the here. Okay, boundary of each face contains what at least 3 edges. using that idea. So boundary of each face is what? Bounded by three edges. F1 is, so that's why I'll put what? Greater than or equal to. So minimum 3. So here also what? 3. Or F2 also. F3 also 3. Minimum. So that's why I'll put plus. Finally, this is what? Each one of them are 3. Now the left hand side is nothing but, the left hand side is what? The number of edges of the face. Okay. So from the definition of uh, what is yes, what is the left hand side? Left hand side means what? Yes, the totally, if you count the number of edges from F1 to Fk is nothing but sum of the degree of the faces. Okay, sum of the degree of the faces is equal to what? The left hand side total. Okay, so instead of this, okay, we can write uh, the left hand side. Instead of this, you can write what? I'll write maybe here sum of the degree of what? Degree of the face. Okay, F belongs to, what is the notation they use? F belongs to script F. Script F denotes what? Denote the set of all faces on a planar graph. Okay, so script F, like this you can use. Okay, this sum is, okay, this total sum, okay, is what? The, this one. But this is greater than or equal to what? 3 times, 3 times total number of faces. I will take F. Okay, total number of faces is what? Here Fk. I will take F is the total number of faces. Okay, F is the total number of faces. But this is nothing but what? Sum of the degree of the faces, twice the number of edges. So 2m you can use, or 2e you can use. So 2e greater than or equal to what? 3f. So now I got this one. 2e is greater than or equal to 3f. Okay, first step. Next, Euler's theorem. What is Euler's theorem? N minus e plus f equal to 2. Or you can write 2 is equal to n minus e plus f. Okay. Now, what is okay? Using this inequality, 2e greater than or equal to what? 3f. So using this less than or equal to, uh, okay, because f is what? From this, f is less than or equal to 2e by 3. F is less than or equal to 2e. So n minus e plus f is what? Less than or equal to 2e by 3. So 2 less than or equal to this quantity. Now throughout multiply by 6, what you will get? If I multiply by 3, 6 less than or equal to 3n minus 3e, 3n minus 3e plus 2e. So totally you'll get what? 6 less than or equal to 3n minus e. So I think this is the result I need to prove here. So e less than or equal to 3n minus 6. So yes, so we proved here. Okay, so what? I want to confirm. We need to prove what? E less than or equal to 3n minus 6. E less than or equal to 3n minus 6. Yeah, okay. So you can write this E this side. So E less than or equal to what? 3n minus 6. So this is the proof. Okay. So E less than or equal to 3n minus 6. The idea is this. Okay. Total idea is what? This portion. Okay. So I am just counting the number of edges of each face. Okay. So that is greater than or equal to, so the number of edges of each face is what? Minimum 3. So totally how many faces I'll take? Fk. So F1 to F1 plus F2 plus F3 plus Fk, I will take what? F. I will take F. Okay. So each face minimum has what? Bounded by 3 edges. So that's why I'll put 3 3 3. So, but this is nothing but, okay. So the number of edges, if you count the number of edges of each face, you will get what? Sum of the degree of the faces. Okay, okay, but that is greater than or equal to what? Three times uh, f. Three times what? F, because total number of faces is what? F, three times F. So with this is, we know that sum of the degree of face is equal to what? Twice the number of edges. That is greater than or equal to what? 3F. So F is less than or equal to what? 2E by 3. And then I am going to use Euler's result. Okay, what is Euler's result? N minus E plus F equal to what? 2. So 2 less than or equal to, yeah, okay, because I am going to replace F by what? F by 2E by 3. That's why I'll put less than or equal to N minus E plus, instead of F, I put what? Less than or equal to 2E by 3. And then multiply throughout by 3 and then simplify. You will get the required result. So number of edges is what? 3n minus uh, 3n minus 6. Okay, well, this is what? 6. Okay, so E less than or equal to 3n minus 6. Next, so suppose this a remark. If the simple planar graph is triangle free, triangle free means it does not have any C3. Okay, so if we have okay, if it is, if okay, if it has C3, then only you can use this idea. So each face is what? Greater or equal to bounded by 3 edges. If it is triangle free means, there is no C3. So then the boundary of each face contains what? At least 4 edges. So the only thing, so everything is same. Okay, so the number of edges of the face F1. Okay, you should write everything. Number of plus number of edges of the face F2, but it should be greater than or equal to, here instead of 3 plus 3 plus 3, you should write what? 4 plus 4 plus 4, because it does not have a triangle, because this triangle free, not a tree. So it's a typo. Triangle free. Okay, it is a triangle free. Triangle free graph. So that means it does not have what? A triangle. So and hence uh, each the number of edges of the face of F1 is what? Minimum 4. So minimum 4 means here you will get what? This is sum of the degree of the faces. Should be greater than or equal to what? Instead of 3F, you will get what? 4F. Okay. So maybe I'll write here. Uh, Next slide. Okay. I'll go to next one. Next one. Okay. So sum of the degree of the faces should be greater than or equal to, uh, I think already 3F means, here now it is what? 4F. Okay. 4F. This is what? 2 times number of edges, which is greater than or equal to what? 4F. 4F, or F is less than or equal to 2E by 4, or F is less than or equal to what? E by 2. So now apply Euler's theorem. 2 is equal to n minus E plus F. So what is okay, now 2 less than or equal to n minus e, f is less than or equal to what? Plus e by 2. So this implies here 2 less than or equal to n. If I add this one, we'll get what? Minus e by 2, or this implies uh, multiply by 4. Okay, we'll get what? Sorry, multiply by throughout multiply by 2. We'll get from this, we'll get 4 throughout multiply by 2. 4 less than or equal to 2n minus e. From this, we'll get e less than or equal to 2n minus 4. So this is the result. So e less than or equal to 2n minus 4. Okay. So now next, using Euler's formula, uh, one can prove that K5 and K33 are non-planar. Okay, K5 and K33 are non-planar. Actually, you can use to prove K5 and K33 are non-planar. This using Euler formula. If they ask in 2 mark question. Otherwise, already I gave the proof for K5 and K3 are non-planar. Already I gave a proof. You can use that one if they are asking big question. Maybe for more than 5 marks or 6 marks, you can use that idea. Otherwise, you can use this one if it is asking 2 mark question. Okay. So suppose if I assume K5 is what? Planar. So by previous result, okay, what is the previous result? So this result, yeah. If it is a planar, then the number of edges is what? Less than or equal to 3n minus 6. So it should satisfy. If a planar implies this one, this inequality should be satisfied. So suppose if I assume K5 is planar, so then the number of edges should be what? Number of edges in K5 should be less than or equal to the 3 times n. N is number of vertices in what? K5 minus 6. But the number of edges is what? In K5, 10. So it's a complete graph with 5 vertices. So n into n minus 1 by 2. So n into 4 by 2. So sorry, 5 into 4 by 2. 5 into 4 means what? 20 by 2 is what? 10. 10 edges. Less than or equal to here how many vertices? 5 vertices. So 3 into 5, 15. Minus 6 equal to 9. So 10 less than or equal to 9. Which is false. So that's why I'll put 1, which is a contradiction. So why we get a contradiction? Because we assumed what? K5 is what? Planar. So K5 is what? Non-planar. Similarly, K33. So K33 is a triangle-free graph. Okay. So because every bipartite graph contains what? Only even number of cycles. It does not contains what? Bipartite graph does not. A graph is bipartite if and only if it there is no odd cycle. Okay. So and hence K33 does not contain odd cycle. In particular, K33 does not contain what? K3 or C3. So that's why K33 is what? Triangle free. So if it is a triangle free means you can apply this result. Okay. Remark. So if K33 is planar, then we know that K33 is planar and K33 is triangle free. Then the number of edges E less than or equal to what? 2n minus 4. So that is number of edges in K33 is what? 3 into 3, 9. Okay, less than or equal to 2 into number of vertices is what? 3 plus 3, 6. 6 into 2, 12. 12 minus 4, 8. So 9 less than or equal to 8. So which is a contradiction. So why we get a contradiction? Because we are assuming what? We are assuming K33 is what? Planar. Okay, we assume K33 is planar. So and hence K33 is non-planar, because if you assume K33 is planar, we are getting a contradiction. So hence K33 is what? Non-planar. Okay, so now we will discuss some of the problems in planar graph. The first one is if every region of a simple planar graph with n vertices uh, and e edges embedded in a plane is bounded by k edges, then show that e equal to k into n minus 2 divided by k minus 2. Okay, so here it is given if every region of a simple planar graph with how many vertices? N vertices, E edges. Okay, now since every region is bounded by K edges, okay, it is given the question. Okay, so N vertices and E edges embedded in a plane bounded by what? Every region is bounded by K edges. It is given the question. Since every region is bounded by put small k. Okay, I think if it is okay, I think here also they'll put small k only. So replace capital K by small k. Since every region is bounded by k edges, so then there are r regions. Okay, suppose we will take. Okay, we will take in a planar graph we have r regions. So each region is bounded by what? K edges means the total number of edges is what? Kr. Sorry, total number of edges. Total number of edges is what? Kr edges. Okay. Also, each edge is counted twice. Okay. For example, I will say here. Okay. So here you can see here. So in this graph, okay, okay, I'll this graph I'll take. Okay, so how many regions? One, two, three. Three is okay. So three is infinite region. One, two, three. Okay, don't confuse with this graph. This is another graph. So here one, two, three. So these two are bounded region. This is the infinite region. So this one contains how many faces? Four. Okay, this is bounded by four faces. The region 2 is bounded by three faces. Again, region 3 is bounded by what? 1, 2, 3, 4, 5, 6, 7 faces. So total number of faces is what? 14. So here 14 is nothing but here they mean what? KR, KR edges. So each edge, okay, so we are counting uh, all the edges. Okay, okay, okay. We are because uh, here what each there are all regions. Okay, all regions. Each region is what bounded by k edges. Okay, I'll stop here and then I will take the problems. Still, we have some other problems. Okay, so I cannot finish now. Okay. So maybe I'll take this portion later. Okay. Thank you.